So before we move on in this atomic structure unit, I want to go back and mention something about the electromagnetic spectrum. This is in your study guide on page 7. And so you've seen this maybe back in the day of middle school or freshman year, and so we kind of know that like the radio waves and microwaves are low energy, and in the middle, infrared means below red, visible light. So you got kind of the visible light spectrum in the middle. Infrared would be a little bit less energetic. Ultraviolet means more than violet, a little more energetic than violet. And of course in this picture they also kind of break down the visible light spectrum. So we know that red colors are the low energy light waves, and up in the blues and violets are my high energy light waves. And so ultraviolet is a little more energetic than violet. And then up on the top, the most energetic, I've got my X-rays and my gamma rays. And so what can these different types of radiation, what can these different types of energies do to an atom or a molecule where there's atoms bonded together? And so if you have low energies, and so we're talking mostly like microwaves or maybe less, especially the microwaves, really all they can do is make molecules rotate a little bit. And it's something that we'll eventually look at when we talk about bonding more, that like we can build molecules out of those like little molecule kits that maybe you would have used in a previous science class. And depending on the type of bond, some bonds will just kind of rotate. And this is a pretty minor change in relation to like the structure of the particle. No bonds are being broken, and so no structures are being changed. The overall structure of the molecule is not changed. The structure of the individual atoms are not being changed. It's just that some bonds allow for rotation. It's usually single bonds because double bonds involve different types of electrons being shared, and we'll get into that much more when we do bonding. I can't wait. But if you kind of think about like just a model kit, and you know maybe you used some of these model kits last year, and so maybe I have like water, H2O kind of looks like this, and so really a low energy form of light would just cause those hydrogen oxygen bonds to rotate a little bit, but no bonds broken, no atoms changed in any way. So again, it's pretty mild in relation to what we could do to a molecule. So low energy causes a pretty minor change, just little rotations. Now if you increase that energy a little bit and we look at the infrared part of the electromagnetic spectrum, now we can start causing bonds to vibrate. This will eventually lead to bonds potentially being broken. And now that is a pretty substantial change to the structure of the molecule. And so this is a little bit more energetic form of energy, and so it can cause a little bit more drastic change. Now we're still not talking anything super wild and crazy, but we can start making the bonds vibrate, and depending on the strength of the bond, sometimes infrared might be enough to not only cause vibrations, but maybe even break the bond. Now obviously as the bonds get stronger, it's going to require more energy to break the bond. But now here in the infrared part of the spectrum, and infrared and beyond, we're finally starting to make changes to the molecule that could lead to bonds being broken. And that's a pretty drastic change. So here AP is going to talk about molecules and bonds vibrating, which is true. I mean, all bonds vibrate to some extent because there's this attraction of the electron cloud and the nucleus, but then there's also repulsion of the two negative electron clouds and the two positive nuclei that are bonded together. And so there's always this natural vibration, but as you add more energy, the vibrations become a little more drastic, and eventually it leads to the bond potentially being broken. Finally, in this visible light, ultraviolet part of the electromagnetic spectrum, we can for sure cause bonds to be broken. And when that happens, there's some kind of a change in the electron structure. And so the electrons can transfer up and down the energy levels. If I'm just talking about like a particular atom, but I can also start breaking bonds in this part of the spectrum. Like visible light and beyond is often when we see a bond being broken. But when you think about like electrons moving up and down the energy levels, often the energy that's released is in the visible light part of the spectrum, which means that that was the amount of energy added to cause the electron to gain energy levels, jump up energy levels. And so it's the same amount of energy that would be released when the electron falls back down to its ground state. So that energy that we see is obviously part of the visible light spectrum, but it could also be ultraviolet. There are times when we have energy gained and released and we just can't see it in the lab. And so these three parts of the electromagnetic spectrum may be parts that we'll end up talking about, especially as we get into bonding. But it's nice that now the electromagnetic spectrum is in front of us and we can kind of look at it. And we are kind of talking about these electron transitions, electrons moving up and down the energy levels. And so the amount of energy that I'm adding to cause the transition is also the amount of energy that's released when the electron falls back down to the ground state. And that's usually either visible light or beyond. I mean, visible light or ultraviolet. And that can also, in a molecule, cause a bond to be broken. So I wanted to kind of look at these three sections of the electromagnetic spectrum and what that energy might do to an atom and what that energy might do to bonded atoms.